Right, welcome to season two of TheForkJoin. I am one of your hosts, Oliver, and my co-host, Rutchit, are here to interview Will about Rust, learning Rust, writing docs, and all sorts of cool TL-related stuff. Will, do you want to introduce yourself?
Yeah, so I'm Will Crichton. I'm starting as an assistant professor at Brown University in 2025, and I did my PhD at Stanford. I'm broadly interested in the intersection of programming languages and all kinds of human factors, cognitive science, education, those sorts of things.
Awesome. So
Awesome.
to start off the
Go ahead.
episode, we wanted to ask you sort of an introductory question, and the question we'd like to ask is, what got you interested in doing research and what makes you excited about doing it?
Mm. Yeah, so I originally was doing computer systems research, uh, kind of in between graphics, like large scale video analytics, and this was fun. So I was always inspired to work on, you know, hard technical problems. I suppose was the thing that originally got me into it. But what I found is as I was working on these systems, I would be building something like, say, a query language for an image database. That was my bachelor's thesis, and then that evolved into like a query language for videos. That was the thing I worked on after. What I cared about was questions like, to what extent do the primitives of this query language map to the way that people intuitively want to express queries on top of image and video content? Like, is what is the kind of cognitive connection between the ways that people conceive of a domain and the way that domain is represented in code? That's a very interesting question to me. And I think that's something that basically every programming language designer or programming system or framework or library designer thinks about. But one thing I found was that when trying to publish work in systems venues that focused on that aspect, it was very difficult to be rigorous. And if you try to be rigorous by, say, things like user studies and so on, that often there was almost even pushback from the community being like, we don't think this is interesting. We'd rather just see this get adopted at a large company, and that's proof enough that this is usable or whatever. And uh, and also conversely, as I read more literature in the PL space, I would see lots of claims about things like, oh, we designed this programming language this way because we think it's intuitive for people, or we think this is more expressive, or we think it's easier for people to reason about blank, where blank could be performance or correctness or whatever. But then there's just no, like, that would be stated up in the abstract or introduction, or even claimed as a contribution, but then there's no evaluation of it. And that really was, I think, what got me interested in, like, well, there's a big gap here that everyone cares about these core human centered questions. Like, ultimately, all programming tools are used by people. And even if they are assisted by AI, they're going to be used by people for the foreseeable future. And so we have to understand them. Like, but we don't have commensurate evaluation techniques with which to understand these human factors. So you've probably seen things like someone might do a line of code comparison. We think our thing is better than this competing framework because programs are on average shorter when expressed with
A
our tool than with the
very
competing
contentious
tool.
metric for
Right.
for
Very
success,
very
yeah.
contentious. And that's because it's a very lossy or poor proxy for the underlying cognitive objectives that it's attempting to measure, which is things like how long would it take someone to understand this program when it was written, or if they were trying to read it? How long would it take someone to debug this program or to add a new feature to it? All that kind of stuff. And
So in
lines of
other
code,
words, yeah, bringing these more subjective things that people claim in papers in a more rigorous light and evaluating them and caring about them, that's sort of one of the things that excites you about doing research.
that's right. In particular, the way I phrase it today is constructing a science of the human factors of programming, which is having metrics, being systematic, both at the end stage, like when you want to make a claim and test that claim, but also equally importantly at the design stage, when you're just starting to build your programming language or whatever, and you don't have time to run a massive user study or your tool isn't ready for that. How can you still be systematically human centered in thinking about the core primitives of your system? I think both of those are really interesting questions to me.
Yeah, one of the interesting distinctions that I think you're drawing, but correct me if I'm wrong, is there's a difference between sort of studying the language aspect versus the abstraction aspect, right? Like, and it feels like quite tight with each other, but you're drawing this distinction that it's really about studying how people abstract and how people think about the abstractions that they want to build when they're building a system, and then how they map it back to the language and its capabilities. Can you talk about that distinction, if that makes any sense, and sort of like how people should think about that when they're trying to build a language?
Right. Yeah, so I think there's this question of so, the word intuitive gets tossed around a lot. Like, oh, I think this API is intuitive, or I think one of my favorite instances of this in recent PL history is there's a press release where I can even show you briefly. So if you search for intuitive quantum programming language, yeah, here we go. There was a press release from this was a PLDI paper out of ETH a couple years ago, and they were like,
Paste it
oh,
in the
this is called Silk, SILQ, and they're like, oh, Silk is the first intuitive quantum programming language, first intuitive high-level quantum language for quantum computers. And they state the intuitive claim in several points in the paper as well. This isn't just like a press release thing. But I think this is sort of funny because by almost any measure of intuitive, I don't think there's like a single person on Earth who just comes out of the womb and intuits the functioning of quantum computing or would intuitively understand what Silk does or how it works, right? That's that's not what intuition really means. I mean, really what they're trying to say is for someone who is an expert in quantum
there.
computing, the primitives of our language map to the way that experts think, right? Once
Oh,
they've been
that's
trained in all of this stuff, right?
because when I saw the word intuitive, what I parsed that as is like this is a distinction between like C or Python, right? Like if you know how computers work really well, C is intuitive in that you get to muck with the memory model and do all of these low level things directly. But when I read intuitive, I parsed that as easy to learn. So it seems there's even not much consensus on what the intuitive word should be parsed
I
as, right?
was thinking that
So you
given that you're
oh,
familiar with traditional computing, like there were
oh,
analogies to classical computing that made it intuitive. So there's three different interpretations for you.
Yeah. So I would say when I think about intuitive, especially when I think about in the case of the design of physical objects, thinking of a simpler setting. To me, intuitive is a person can look at an object and understand its function and how to use it without instruction. Because usually they can, and this is what we're saying, they can map onto it by analogy from other things that they understand. So for instance, there's a so Don Norman is a cognitive psychologist who's written a lot about product design, and he has this concept called Norman doors, which are doors that you need instructions on the door in order to understand how to use them. Let me see if I can find a good example. There's lots of them, but if I just do a quick
I
Google
go.
search and share my screen, you can see. Right. So this is like when the door has to say pull and you're not sure what to do, or if right? Something like this, right? And
Right.
it's like I have to put this very clearly because otherwise you're not going to get it. Then the idea is that's often a not intuitive design is if you require instruction in order to understand the function of something. So in like simple products like doors, that's kind of to what intuitive means. And the challenge, I think, like there's a much bigger challenge that this is hinting at, which is we have this established vocabulary of talking about human factors from traditional domains in which human factors are applied. So this is ergonomics, product design, user interfaces, and then we import that into the domain of programming languages. And this is just
Hmm.
a completely different sphere. Like imagine if I try to say like, oh, I think English is intuitive, more intuitive than like Arabic or something. What does that even mean? No, we learn languages. We don't really consider any of them to be more or less intuitive. I mean, certainly we can make arguments about their relative complexity and whether some alphabets are easier to pick up than others or whatever. But at the end of the day, you would never say a given language is just intuitive because no one comes out of the womb understanding language. Maybe it becomes intuitive once you know a language and you can start to draw analogies, but it's so heavily contingent on your background. It's just, or I think another way to say it is like especially for programming languages, they rely on such niche technical expertise that this like assumed universal background that someone should have for how to say open a door is not there for how to program a quantum computer, right?
Mm.
Um, and I think that
I,
this is just a good example of like a kind of this is the sort of thing where I want PL designers to have the right vocabulary and to be more systematic and to not make claims about things like languages being intuitive when I think they really mean other stuff.
So this might be a good opportunity to tie it to some of the work you've done in the past. Where is a place in your work where you've thought about what makes something intuitive or what makes something easier to learn by relating to previous knowledge?
Yeah, so this has been a focus of mine in the last year. We've been thinking about how to teach Rust in particular. So broadly speaking, we have this research agenda about there are lots of people trying to learn Rust right now, and Rust is a difficult language to learn because for many developers, it pulls in concepts that they are unfamiliar with, whether it's functional programming concepts like algebraic data types, or entirely new type system concepts like affine types and ownership, and or even for some people, they have no systems programming experience, and so they have to learn Rust. And in particular, we look at this problem in the wild, like a random developer comes off the street and says, I want to learn Rust, and I'm going to open the Rust textbook. People have built resources, but again, there's no systematic way by which to understand the quality of those resources and how well people, like the level of learning outcomes people are getting when they go off and read a Rust textbook. Um, and so that was kind of the broad impetus for this project. How would we understand the learning challenges people face when going into a language like Rust, and then how would we develop things to make it better? And the sort of long story short is we found that people uh didn't really like they that all right, let's see, how do I get into this without taking too much time? So let's talk Rust for a second. Let me bring up the Rust book.
I'm sure everyone wants to talk Rust for a second, so this is a good
Every
topic. Yes.
That's right. uh so if you go to the Rust book, like if you say, all right, I'm gonna go learn Rust, so the place you're gonna pop into is, this is doc.rustlang.org slash book. This is the Rust programming language. And then at some point, you're going to get to understanding ownership. And you're going to say, how does ownership work in Rust? And
Shouldn't be too hard, right?
basically, imagine if you don't know much about systems programming. There's like one big blue box that like tries to tell you everything you need to know about the stack, the heap, and memory, and pointers and allocations. And then it's like, all right, moving on. There's a bunch of rules, and then here's some things you can do wrong. Like, what's an example they have here? Let's go to references and borrowing. They say like, oh, if you have an immutable reference to something and then you try to mutate it, that's bad because the compiler doesn't let you do it. Or if you have two mutable references to something, that's bad. You can't and actually this is a really good and interesting example, just picking randomly from the book, is you say, let mute s equals string, create two mutable references to that string, and then print them both out. And this is rejected by the compiler. I don't think the text even talks about this, but this is a false positive from the compiler's perspective. Like this is rejected
You
by the
didn't mutate
compiler.
anything, so like
Correct.
it should be
No,
fine in your mind.
exactly. Print is a read-only operation, and therefore this program is like provably safe. There's no undefined behavior that would result from any of these operations. But because you programmed it this way, you violated this sort of heuristic that the book is proposing, then you start to run into trouble. And I think this is the real issue we found in the style of Rust pedagogy that you find out in the wild when people try to explain this aspect of the Rust type system, is you would see like, oh, here's a situation where the compiler doesn't like what you're doing. So if you have two mutable references to the same thing, you're hosed. And it wouldn't, and all additionally, the pedagogy would not usually explain why. And in particular, because that would lead to the realization that there's not a good reason, or the reason this program is rejected has to do with soundness versus completeness, right? This is an incompleteness issue in the type system, and it's not because this program is actually unsafe. That is not a distinction that programmers are being led to realize. And so,
There's this tension I think that you're bringing up between the principle that the compiler sort of espouses and tries to have you think about, which is that you shouldn't mutate
Hmm.
shared data. And then there's this system that implements that, and it uses a heuristic, namely the type system and the bar system.
Yep.
And there's this tension between the mental model of the principle and the mental model of the system, right?
Yep.
And there's some amount of refinement that needs to be done as you start using the language. But I do want you to talk a little bit about, I think one of the big sort of victories of the Rust type system and the way it forces you to think about is it really, like, if you're coming from a background where you do really know very little about systems programming, it will teach you the right defaults, right? Maybe it'll teach you the right defaults for the wrong reasons, which is an interesting point and maybe worth thinking about.
Mm.
But it'll teach you the right defaults, and that's something like, for example, I think about in my work when we're building hardware description languages and we want people to write programs in a way that they can generate really efficient circuits. Well, I
Yeah.
can't teach you everything about circuit design. I can't teach you about clock trees, and I can't teach you about power domains. But I
Hmm.
can teach you that if you try to read a memory more than once every clock cycle, that's bad, because memories are these physical entities and they can only allow
Yeah.
one read every clock cycle or something, right? And so what is this? How do you think about this tension between the principle and the system, and its relationship between sort of the pedagogy that we need to use to teach people the difference, right? Because
Yeah.
we want the pedagogy to allow someone to take ideas from Rust and be an effective C++ programmer also, but we don't
So
want them to be confused with the system.
right. So I think that's fair, but I think whether Rust makes someone a better C++ programmer is an interesting question, but is even like far outside the scope of the sort of smaller problem I'm thinking about right now, which is just, is someone even learning Rust well? Because the problem I am trying to address that we would observe in practice is when you teach someone Rust in the style like you see on the screen here, the problem is that this there's a concept in computing education of transfer. Like I teach you a concept in a specific set of settings, I use a specific set of examples, and then I give you a new example and I say, now solve this problem that you haven't seen before. And the farther that example is from the context you learned in, the farther that, the greater the transfer distance, more or less. And the holy grail of computing of any kind of education is robust transfer. Did you learn some generalizable knowledge that you can put into lots of settings? And that's really the main finding is there's a lot of relatively basic settings not covered by the Rust book that people struggled to understand when confronted with a compiler error about ownership.
It does make
So
you wonder,
Mm.
like, the concepts of coverage can be pretty well defined. Like, you can
yeah,
cover all of the errors in Rust, uh, and then make sure you're getting all of them in your examples.
exactly. And so just as as one example, the way we actually were systematic about this question is we went to Stack Overflow and we looked at the most frequently referenced questions involving ownership. And it was interesting just to see. So these are questions that people keep repeatedly asking that seem to continually come up in new contexts. And then so the old questions get linked to again. And so you'd get stuff like cannot move out of value, which is behind a shared reference when unwrapping. And so concretely in this setting, you have like a reference to some option and you try to call a method that wants to
Right.
move the input and it's not allowed to do that. That's what unwrap does. And so what we were finding, it was first of all the realization that all of these Stack Overflow questions are out there and keep getting posted suggest that these represent common examples of failure to transfer. These are kinds of situations where people are consuming Rust learning resources, going off to write Rust in the wild, and then encountering an error, which is fine, but then not able to solve it. That's the key thing. They aren't able to like build a mental model of why is the compiler rejecting my code and what would an idiomatic fix be? And so that was ultimately the problem we set out to solve was giving people a more robust conceptual model of both really the principle and the implementation, I think, to your original point, Wretched, which is like both what is the compiler trying to protect you from and what is the mechanism in the compiler such that you can start to distinguish between false positives and false negatives. And so very briefly, the thing that we ended up doing is we embedded two kinds of diagrams into the book. So first we we created a tool that can automatically generate these diagrams from Rust programs, and it shows like stack and heap diagrams. This is just basic stuff to give people a visual representation of the state of memory at different points in the program. But more interestingly, then we could relate these and say, so here, like if you have a vector and then you create a reference to that vector and then you push an element into the vector and then you print out a number, then this is bad because it'll look like once you create this reference and then push into the vector, that invalidates the pointer you had on the heap. And so when you read it, that's a use after free. We can see that in the diagram. And we want to relate this. This is, like the thing about dynamic versus static semantics. We need to relate the dynamic semantics to the static semantics here. And so the static semantics we convey through this like permissions model. This was really the main idea of the research, was that we can rephrase, in a sense, the information that comes out of the Rust compiler, like the borrow checker, into these letters that indicate the different things you're allowed to do on a given line to a variable. So like when I create this vector v, I can read it, write it, or I can own it. Like I can drop it or move it. And then when I create this number, this reference, I'm not allowed for the duration of the live range of this number to write or drop the vector, because that would cause some kind of issue. But then once I'm done with this number, I can go back and push into the vector.
And this is very powerful because it's information that you could never see before. Like just looking at the syntax, this is all stuff that you would really have to execute the Rust compiler in your head to infer that like this is the state of that variable at this particular point in the program. So having it all laid out like this, super powerful tool, a big win for visualization.
Yeah, that's exactly right. And there's a much broader theme here about as type systems and static analysis tools become more pervasive and more complex, there is a corresponding need for tools which externalize the information generated by those type systems into your editor or into whatever environment that you're using. Because otherwise, people will just have a very opaque black box model of what's going on, and that's not going to be sufficient for them to debug these tricky issues when they run into them in practice. Because the goal here of this conceptual model, in particular of the permissions, is to help you understand, like, so from a PL perspective, we would say, like, the borrow checker is kind of abstractly interpreting your code. That's a useful way to think about it. Is the borrow checker looks at your code and squints, and then all it's seeing is operations that read or write or own. It doesn't know anything about the semantics of like print or push. It just knows that push is a write operation, print is a read operation. And therefore, that's the only thing that I care about when I squint this way. And the key thing then is when you squint and you lose information, how does that, for instance, cause false positives? And so one thing we put into the book that I really haven't seen almost anywhere else is this page on like fixing ownership errors, and in particular getting to, like, we distinguish between fixing an unsafe program. So this is like here's something that's genuinely unsafe. This is undefined behavior. Like if you return a pointer to something on the stack, you can't do that. But then we also talk about
Fixing
like
programs that are technically safe, but Rust rejects it.
Exactly. So
I see.
fixing a safe program. So here's actually a really good example that comes up a lot in practice, which is, let's say you have like a tuple with two fields and you borrow one field, and you can see when you borrow it, you like the overall tuple and then that one field of the tuple lose write and own permissions. But then I'm allowed to write to a different field of the tuple. Rust has, you would call this field sensitivity in certain cases. But then if I
But when you're outside of those certain cases, which I
yeah,
frequently am, then I suddenly don't know what to do.
exactly. So in
Yeah.
this case, when you just pull this expression behind a function definition, right? That extract into function operation effectively like erases information that was available to the type checker,
Yeah, this is
and therefore,
relatable for sure.
yeah, and therefore this now considers it to be a borrow of the dot one field when you call this function here, and this is now rejected because you don't have permissions on this thing. And this is just a really good example of a kind of distinction that previously I don't think was ever brought up to Rust programmers. And so, I mean, I've personally, when teaching people Rust, encountered these situations where people would write this kind of code and say, well, what am I doing wrong? Like, what's unsafe here? Why can't I do this? I think this is reasonable. And the answer is, it is reasonable. You should be able to do that. It's not your fault, right? You're running into an incompleteness issue, and in particular, there's entirely different sets of mechanisms that are appropriate to solve a false positive and a false negative.
Right.
Or sorry, false positive and a true positive, I should say. Um, which is when your code is actually unsafe, you have to change the code. You're fundamentally doing something wrong and you need to re-architect your code. But when you're doing something that is safe, but just you can't convince the compiler, then there's a whole bevy of mechanisms that are appropriate for those situations. And I think one of the theses of this work is that teaching people both about this distinction and giving them basic training in making this distinction is very useful on the ground knowledge for having a more systematic practice in dealing with ownership errors, as well as in designing programs for ownership from the ground up.
Awesome. Yeah, that was a
This is
great.
a really
Yeah,
concrete sort of example of the distinction between sort of like the kind of distinction I asked you about. This is great, which is like you summarized it by saying there are true errors and you like there are points in time when Russ will tell you you're doing something wrong and you're truly doing something wrong and you need to be able to distinguish those from like the compiler can't actually be convinced of this being true, but that this is a correct thing. And it's that's a very sort of nuanced and sort of interesting way to think about it. And I appreciate that sort of perspective on it. I think just thinking in terms of time, I want to sort of pop up the stack a little bit and talk a little bit more about this like science of programming languages design from the cognitive science perspective that you're talking about. So you solved a couple of questions. You've been thinking about this area for a little while. I want you to give us some sort of like an overview on what the space looks like and what kinds of questions do you think are sort of the most exciting questions that you want to think about in the next couple of years and how those influence how the field of programming languages and cognitive sciences, CS they're going to be influenced by that work.
Yeah. So I think one big area is about a mixture of design principles and experimental methods, which is concretely you are a developer on a advanced cutting edge language. So let's say that is Rust or Lean or Halide or something. And your goal is to get more people to be able to use your language. What does that look like? How do you be better about that than just the practice that exists today? It's a very broad question, but I think tackling that from several angles is one driving problem I have, because I think we're reaching this point where the complexity of PL tools and research has so overshot where the average developer is that we have tools that can do amazing things, but require close to like a PhD in both math and PL in order to understand them, that we it's we are held back by our ability to teach people about our tools and to make them more accessible to folks. And so concretely what that looks like on the ground is a few things. So education is one component. Like, how do you design better textbooks or better tools to teach people programming? So I think improving textbooks is one thing. So like I just spent a long time talking about the Rust textbook and how we've done some stuff for that. I think another really interesting question to me is on-demand learning, which is most people don't want to sit down and spend a month reading a textbook and then go off and solve their problem. They want to start with the problem that they care about and they work backwards from there, learning just what they need in order to accomplish their specific goals. And that the problem with that is best served when you have an expert sitting over your shoulder being like, oh, you're going to need to use this, this, and this. Go read these docs and then come back and then try this. But that's we don't have tools that are effective at that. Maybe AI stuff can be useful, and I think there's lots of ideas about how to make this more practical. But I think that in general, that's a really interesting educational direction to me. Is how do you help self-directed learners be more effective at diving into complex tools where they're never going to understand everything, but they can understand enough to be productive at the stuff that they care about. That's really
right.
interesting to me.
I
Just as
feel
a
like
concrete
from
example.
personal
Oh, go ahead. Yeah.
experience, learning about something that I'm actively working about and like reading the particular little section of the docs that's extremely relevant to my problem that I'm solving right then teaches me a lot more. The lesson really sinks in. So if there's
Yes.
tools that direct you towards that, that would be super useful.
And even a concrete example of this is like I spent some time at the Graduate School of Education during my PhD, and I watched people who were very smart sociologists and other such folks go off and try to learn enough coding that they could like do data science. And it's just so painful to watch them flail around with the like terrible pile of tools that we hand them and hope that they learn programming, and then they cry and give up and then go wait for their TA in office hours.
Yeah.
There's so little support for a self-directed path, especially for people who have little programming experience, that I feel like there has to be a better way. And I think AI will be a part of that, but I think there's something more foundational about understanding that learning process. Like you can't just throw, Copilot or whatever or Claude at it and be like, people will figure it out. Because when that tool doesn't work, what do you fall back on? That's really an equally big question. So supporting those workflows is interesting. And then the other thing I'll say in that direction is in the direction of systematic design of programming languages is how do you gather feedback about design decisions, or how do you identify usability holes in your language? Like I actually just gave a talk like a lean symposium about how this could look like for formalized mathematics. I don't know if either, I mean, y'all probably experienced with some kind of proof assistant, but these are gnarly tools that we don't currently have great ways to teach people about them. And I I think there's all kinds of interesting questions about, for instance, if you wanted to put telemetry in your tool chain, if you were going to gather information from people as they were using your tool, what kind of information should you gather that's going to be most helpful in informing your design decisions? Or if you want to develop better search tools, or if you wanted to develop better user interfaces, better IDE extensions or language servers, what features do people need? Where should you invest your precious resources, right? Should you be making your error messages better? Should you be building a better like goal pane? What does better even look like? Again, people do these things. They just have a very ad hoc approach to them based on their intuition and the people they talk to and what they see filed in their GitHub issues. And so I think tackling those kinds of questions, both by gathering more data from the ecosystem so you can be more data driven in your understanding of where the problems actually are, but also pulling in ideas from cognitive psychology about like when I want to go off and design a learning environment for lean, or I'm going to go off and design a search tool for theorems or something, how do I make that maximally effective? How can I teach people about my query language? All of these kinds of questions are the ones that I'm excited to answer. So that's one side of the research agenda.
Yeah, and one that's relevant to everyone who's designing a tool, which is the goal of many people. So,
Right. And that's
well,
part of the reason, I work in the PL community as opposed to say as much the CS Ed or HCI or SE community. Is like I would much rather be the person who's like next to the people who are designing these tools. Like I want to talk to the people who are designing Lean and Halide and whatever, and then publishing papers at the same conference and being like, you're writing your documentation right now. Here's some like useful things you can use, as opposed to talking to other people who all care about human factors, but they're not the ones who are implementing the tools that then people are being faced with. So just that's some inside baseball, but I do feel somewhat strongly about that aspect of the interdisciplinary work.
yeah, that is the interesting thing where like the PL people and HCI and other areas that care more about human factors are very split and don't talk to each other. So you bringing those
Mm.
together could be super useful.
I mean,
Perhaps it's
one
time
specific
to
challenge
sorry.
around this. One last question just to
Yes.
satiate me. That one specific challenge here is also that a lot of the people who are designing these new languages are not really publishing at the PL conferences. I don't think a lot of the people who build languages that actually are sort of being deployed and being used by people classify themselves as PL researchers or even publish in the communities. There's like awesome like PL work that happens at VLDB or like AskFloss and all of these communities. And in some ways, those communities feel so far from the core PL community and sort of the standard ideas and thinking in terms of semantics and formalizations and strong guarantees. How do you get those communities to adopt the ideas you're building within the PL communities quicker, right? Like I think that's like either we wait 20 years for them to pick up the semantics part and then get to the coxi part, or we somehow entangle them so profusely that they're so inspired to use those techniques, right? Like for those people, I think it's important that you give them a value add. So like if you
Yeah,
had to pitch like, here's the value add for your tool, what would you say to like an architect or a database engineer?
right. I think I think there's two different questions. One is what would I pitch them, and broadly speaking, what is my strategy for getting connected with them? Speaking of the latter first, I think I have two basic approaches. One is, of course, go talk to them, try to, find an opportunity to speak to their research groups, keynote their conferences, and so on. But I actually think an equally effective one that informs me is just building successful tools and having them out in the world is as strong, if not stronger, than almost any other form of technical communication you could accomplish. So what I mean by that is
Mm.
like when you build a successful tool that lots of people use, that tool embodies certain claims about how tools should be built, right? The fact that Rust exists and lots of people use it is an argument for things like algebraic data types, a good package manager, ownership, whatever, right? Far more so than like individual papers arguing that these are a good idea, the technical thing itself propagates that concept. So anybody who uses Rust, then when they're designing a new language, goes, "Oh, I remember algebraic data types. They're pretty useful in Rust. I'll put them in my language too." Right? And I similarly hope that's going to be the case for for either the language itself or the tooling and pedagogy that's built around it. That when people go off and read a really cool Rust tutorial, say, they go, "Wow, that's a really interesting idea, visualizing a type system that way. I should think about how to do that for my own language." That I genuinely believe is more likely to cause greater change in the long run, especially outside of academic circles, than publishing the paper. But I do think that the paper is still important because it allows you to convey your ideas and the intentionality behind them with greater clarity than simply encountering the thing in practice. And of course, talking about statistics and all kinds of things that you can't convey through just the tool itself. But I think that really designing good tools and putting them out there is more effective than people think, right? Or if anything, right, I think about how many ideas that people have like never heard about from the 70s and the 80s, but the ideas that do live, they persist in the programming languages from that time we still use today, right?
Mm.
So I'm very much a like an artifact maximalist as a mode of communication.
Yeah, that's I think I find that sort of philosophy quite inspiring in the sense of like it gives you a strong motivation as an academic or someone whose nominal job is to write papers and communicate the research only, to have that motivation to build and maintain tools for long periods of time. I think
Well,
all of us have built tools like this and have tried maintaining them. And it's a lot of hard work. It's a lot of work that is not necessarily, things that are represented in your citation count or sort of these standard metrics that academics use, but it's super valuable. And the part I really appreciate about the process of maintaining these artifacts is you get to see a depth of a problem that you don't get to do if you sort of write something up, code it up, publish, evaluate it, and then leave it to die after your paper is published. So I think there's lots of good things about doing this kind of like artifact maximal approach of building these tools and working with them.
and people can't help but want things that they've used in tools that they like. Like once you use something once, you're done forever. You'll expect that in every setting ever.
Right.
Yeah.
Yeah, I
Yeah.
totally agree, and I think then the sort of room for theory, and I think is or a good example of this is like interactive programming tutorials. If you said I want to build a better programming tutorial for my language right now, there's actually a lot of content out there that's pretty good. Like for instance, many JavaScript frameworks now have their like interactive playground tutorials you can use. Lean, I think, has an interactive book, as does F Star. Lots of people are really interested in building better ones, and so there you more run into the question of, well, which of these designs is good or better? Which one is an appropriate trade-off of the effort I'm putting in to make my materials better is going to provide a commensurate return on my investment in providing, say, better learning outcomes for people trying to pick up my tool. That's the sort of more theoretical questions that really is where research is best equipped to answer that. And you can't just get out of try trying all these tools in the wild and then seeing what works for you. You kind of need something more rigorous than that.
All right, so we have about 15 minutes left. The two sections that we still haven't gotten to are audience questions and our closing question. So maybe it's time to take Pletrek asked a very interesting question, which is if you have now understood Rust type system super well and you've understood how people understand Rust type system, has that given you any ideas about alternative ways to reason about memory?
Yeah. So I think that it's having worked with Rust for several years, one thing I find really interesting, and actually I don't think we've fully addressed in our work, is what is a lifetime? which is another way of saying that is how do you reason about aliasing or reason about dependencies in the type system? Because ultimately, that's a lot of what the trickiest parts of Rust are about is like, I hold some reference to this piece of data over in this data structure. And from Rust's perspective, Rust cares about that because Rust really wants to make sure like I can't if I refer to some object, then that thing must live longer than the reference, or else you could run into a use after free, right? But there's a much broader question, which is how do I know what points to what? That's and that I think is really interesting because you find that in other contexts. You find that, for instance, in reactive programming when you want to track dependencies for the purposes of performing incremental computation. And I think there are lots of other settings where you care about fine-grained dependency analysis. And and like what's been interesting to me is how lifetimes, especially the phrase lifetime, is often interpreted as like a lifetime is the range of code where like a reference could live or something. But as people have done research on this, like both people have tried to build better borrow checkers and people like myself have tried to build tools derived from the borrow checker to do other things, uh, then you start to realize like that's actually not the best way to think about what a lifetime is. Another equally valid way to think about is like a lifetime denotationally is the set of things that a reference can point to. It's like you're baking an abstract interpretation kind of into the type system of like this thing is the approximation of the points to set of any pointer that has this lifetime. Uh, and so I think that's something I can let's see. I'm forgetting off the top of my head, but I can link some resources that like Nico Batsakis has talked about this, and there's some other as well as the oxide work that I've used. The oxide formalization of Rust is based around similar ideas. I think there's a lot of yeah, that's really been a big shift in my thinking. Is just that there's different ways we can think about tracking aliases in the type system, and the lines of code one is less useful in a lot of cases, and potentially even for the basic memory reasoning, than I think this like alias set oriented view.
Yeah, I think more broadly, many people have the view that Rust figured it out. It's like over. You know what I mean? Borrowing, they got it down. But
Yeah.
while Rust has lots of good things that are very helpful, I think you're pointing out that, we might be able to do a lot better and think about lifetimes in a different way, with some
Right.
more effort.
And y'all are gonna have May Milano on, I think, next soon,
Right.
and so
Yeah.
I'm sure she'll have a lot more to say about
Stand up. Yeah.
that. Shout
Great.
out.
Um, cool. I think that's the only audience question we have currently. So I think we can also move towards the end of the conversation. If folks have other questions, we can sort of pipe them in or follow up with Will later on. Um, so one of the things that we asked folks to think about when they show up to the podcast, especially in the setting, was like, what are other metrics of success that you think about as an academic, especially in academic building systems? I think you really already touched on one of the more important ones for you, which is like building artifacts and getting them used. What are some other ways that you think about sort of communicating your research, your lab's research, and sort of what is the mental image of a successful academic, someone who gets a PhD, for example, through your lab? What would you want them to have and think about as they're going through the project
Hmm.
process?
So I think very broadly, just about like my philosophy and the lab's philosophy, I think there's a certain strain of thought in the PL community and in the systems community that I alluded to at the beginning, which is human factors work is untenable in the systems or PL setting. And this can take several strains. This is because traditional HCI methods don't work in our context, which I do kind of agree with. This can take the idea that it's just too complicated of a problem, and so the only way to determine which tools are more usable than others is to let the market decide of which people adopt, and that's not our provenance as researchers to figure out. That's for implementers and industry to go off and decide. And or conversely, like the only way to determine whether your tool is usable is just to get it used. Like if the only thing I want to see in your paper is when Amazon has adopted your tool, and until that point, I don't talk to me about human factors. And I disagree, strongly disagree with all of these attitudes, because I I believe and have good evidence to back up that people are engaging in human-centered reasoning at almost every step of the design process of any tool that is fundamentally user-facing. They're just being ad hoc about it. There's no rigor, there's no systematicity. And so that's the thing. To me, success at like a global scale is getting the community, be that both researchers in programming languages, programming systems, as well as practitioners as well, to both recognize the importance and the cases where it is most important to sort of think in a human-centered way to incorporate human factors, as well as more productively to construct methods that and principles that people can use to improve their own work, and to build tools that exemplify those ideas so people can look to them as exemplars of like, this is this is how good you can do when you think in a human-centered way. um like I think a funny instance of this is I've seen a lot of PL papers or papers published at PL venues in the last 5-ish years, increasing numbers that have started to include user studies. And I cannot tell you how many of them have negative results. That like people previously it would have been people just spent all this time being like, I'm sure our thing is great for humans and is very user centered. And then they would publish like a performance evaluation and be done with it. Right. And recently we started realizing, okay, that's probably not enough. You should actually test that claim. People test the claim and it turns out their tool doesn't help.
Oh
And
no.
it's like, what are we doing here?
Do
This
do you
is
have examples of these? That's very interesting. I
I
think that would
remember
be
seeing one at Oopsla just this past year. I'm also like, I don't want to call up people's individual work too much. But I can perhaps share a list with y'all after just to back up the claim a little bit. But it's definitely something I've seen where when people actually put the tools into practice and they try to perform some traditional HCI style user study, you end up with something where you go, oh, actually our tool doesn't help nearly as much as we thought we did. And I think a really good instance of this, one of my favorite examples from the literature is uh, Raft, the Raft consensus
Hmm.
protocol. So I don't know if y'all know the backstory to this, but very briefly, Raft versus Paxos as a means of consensus was originally designed as a better way of, or their idea was that they felt Paxos was literally just too confusing, and something they thought was less confusing as a means of implementing distributed consensus. And the question was, well, how do they show that? And what they this was a long back and forth within the systems community. Uh,
A
and what they
classic
eventually ended up
rivalry.
doing, yeah, what they eventually ended up doing is they literally like ran a class at Stanford and Berkeley where they taught people both protocols and then created a test that measured their comparative learning outcomes in like both settings, and it was very well designed. It's a cool idea. You go check it out. But the test difference was like very marginal. They're like, oh, when we give people Raft, people get like 4 more points on a test. Something where you would look at that and go, oh, that's kind of whatever. But then Raft is huge. It's used by like everyone. This is one of the most significant ideas of distributed systems, as far as I can tell, that came out of academia in the last 10 years. Because I think people find it more understandable and therefore easier to implement, and people like it a lot. So that just speaks to the fact that the tools we have to back up our like researchers' genuine intuitions about what makes things understandable or whatever, just completely incommensurate. And that kills me.
So
That
you're
makes me so sad.
so you're saying some
Success.
people tried. They like set up the experiment really in a reasonable way and measured this test thing, and it still didn't show strong enough results that you expected. Like we're still not doing
Exactly.
good enough at measuring why Raft is more intuitive in your mind.
Exactly. And so to bring this around, success for me is developing and disseminating methods, principles, and tools that can elevate essentially the discourse around human factors in programming systems. So that way, researchers have better tools with which to evaluate the human factors of their systems, and the power of those tools is commensurate with the expected sort of power of the tool in practice. Uh, and as well as, I mean, just we build tools that are better for people, that we help people use powers to their use computers to the greatest extent possible, that anybody can learn to use Rust, anybody can learn to write lean. That's also part of my philosophy. Is I think success is defined by democratizing access to our most powerful computing tools.
Yeah. Empowering users and keeping it real. Well,
That's
thank
right.
you very much, Will. That was a very good response. Any other questions before we wrap up? We have 5 more minutes.
I had a maybe somewhat self-serving question in this space also, in that we're talking about the use of human factors research and sort of engaging with that early in the design process. One of the things that often shows up when you build systems is trade-offs, right? And so when you're building a language, let's say something like Halide, that's primarily claiming that you can sort of build higher performance systems more easily.
Mm.
Um, how do you balance, the arguments about, well, this language clearly lets me write higher performance things, right? Versus, is this language easier to use? And so what should be sort of, how do you think about the trade-off space between sort of these very quantitatively measurable things that, again, the metrics in the community and how we evaluate them, that feels easier, right? Like if you give me a bar chart, I know how to interpret a bar chart on performance. It's much harder for me to interpret something like, this language feels more usable, and this is precisely how I interpret that. So how do you think about that trade-off? And how should we as a community start thinking about measuring and evaluating those trade-offs? Because they are trade-offs, right? Like something that is high performance, if it's compromising on usability, but it's targeted specifically on an audience that is maybe sort of higher expertise than the standard programming audience, then maybe
Right.
that's okay.
Yeah. It's funny. Simon asked me basically an identical question, and
Ah,
so it's on people's minds. And I think the first thing I would
right.
say is I am very careful about the word usability. I think it has a specific connotation, often to the extent of like dumbing something down, simplifying it to the point of removing its features or making it more accessible in exchange for making it less expressive. Um,
Mm,
and and again, that's a bit of an ethos that comes out of HCI, where I think in traditional, especially the last 20 years amount of HCI work, it's been very focused on, again, like intuitive interfaces, things that you can learn in 15 minutes, things that should make you powerful without requiring a lot of effort from you. And that's just not how programming languages work. And but I think that's the frame of mind a lot of people bring in when they talk about things like usability. So when it comes to something like Halide, to me, the more interesting question is, to what extent do the primitives provided by the language map to the ways that people think about these problems? And I think that's the genius of Halide, right? Is that the scheduling language specifically provides various primitives like sliding windows and batching along various dimensions and so on that correspond to the way that performance engineers were already conceptualizing their existing C and C++ code. Like if JRK had picked a totally different set of primitives based on some
mm,
alternative metric. I'm not even sure what those would be, but if you picked a totally different set of primitives based on like polyhedral optimization or whatever, then you might end up with a completely unusable programming framework because people would go, I don't know how to express my image processing pipeline in these terms, and it takes me a long time to figure out how to do so. And then I change my pipeline, and it takes me a long time to figure out like the right way to update my schedule to match that, or it's difficult for me to explore the scheduling space. Like I think a really the best user centered thing, or a very fun user-centered experiment I've seen in the Halide space specifically was Kayvon had an experiment in like an auto scheduling paper where he showed basically two performance engineers at Google writing Halide schedules and how fast they could make like the maximum performance they could eke out over time versus an
mhm.
auto scheduling thing to see like, well, how much work does it actually take, like how many hours of work does it take to get to something that's performance competitive with what an auto scheduler could produce? That's an interesting question to me. Like that's a useful kind of experiment you could run, which is for someone with deep expertise who's working in a debugging loop, how long does it take before they can get to something that a computer can produce? How much farther can they
Like,
go than what an auto scheduler can
that's
create? Yeah.
optimal or not, it's how quickly can you get towards 75% of optimality, because that's what actually matters when you're
Yes.
in this iterative loop. It doesn't matter that you can synthesize the best program. It's like,
Yeah.
can you give me enough tools to get me towards the direction I want? And sort of this notion of feedback.
Exactly.
That's
And
sort of
so
like a, please.
yeah, no, I was gonna say just to pin the thought, I think really what we care about is measuring the phrase I like is directness of mapping. To what extent does the primitives of the language map directly onto the primitives of thought? How you conceptualize a problem domain. And measuring that is a really interesting question. I will say briefly one idea I've had for a long time, I think a very cool experiment to run is that um, I think people like to proxy directness of mapping by lines of code. They say because programs in my language are shorter when implementing this benchmark of tasks, that is one way to argue that with fewer lines of code, there is a more direct mapping because you have to sort of say less. But I think that doesn't. The problem is you can still have a short but difficult to understand program. Uh, I would argue that a better proxy for directness of mapping would be when the proof of correctness that your program, or when you can prove that your program is correct, the length of that proof is probably a more interesting proxy for things like directness of mapping and other cognitive metrics than the length of the program itself. Um, this is a hypothesis I've had for a long time that I've been meaning to find a setting to investigate. But that's just one instance. And if that was true, then you now have a new metric you could give out to the community and say, hey, rather than measuring lines of code, go implement your thing in a proof assistant, all you people who know proof assistants, and then measure the size of the proof instead.
Yeah, that's
Uh,
actually a metric that I've been thinking about myself for a compiler project I'm working on because we claim that our IR is easier to write optimizations for, right?
mm,
Because like LLVM optimizations work on a CFG and it's tons of lines of C++, and we have like some more structured IR. But
yeah.
we can't just measure lines of code, obviously. We've talked about that several times in this stream. So one thing I've been thinking about is maybe it's easier to prove optimizations correct. The problem with that, like you were alluding to, is that it requires a lot of expertise and time to prove optimizations correct,
Yeah.
especially for compilers. So that's gonna be hard, but I think it might be well worth it if we can show that things are easier.
Yeah, yeah, that sounds like a cool project. You keep going. I like that idea.
Yeah, maybe. Well, I have a
Right.
PhD to finish up, so maybe I'll spend the
Fair
rest
enough.
of it on that.
Okay.
Yeah.
Right. Okay. So to wrap up, last two questions. What are three papers that you recommend people read or that you've enjoyed reading? And these can be your papers, they can be sort of foundational papers in Coxsci or sort of contemporary paper that you think does a really good job of sort of discussing the kinds of trade-offs we've been talking about.
And we also
And
had a question for what papers do good user studies. So you
Mm,
could wrap that in as well if you want to.
yeah,
right, and I think you should sort of remind people about your lab and what you're doing and when you're recruiting and so on at the end.
sounds great. So briefly, papers. If you want to read one of my papers, I think a grounded conceptual model for ownership types in Rust, which I published at UPSLA in 2023, is a really good example of the full pipeline of what I think human-centered design work in PL, at least education, PL education looks like. So I like that paper a lot. And in terms of cognitive science papers, one really fun paper that had a big impact on me is a representational analysis of enumeration systems by Jiajie Zhang and Don Norman. This paper basically looks at it systematically enumerates the properties of different notations for number systems across the various civilizations of the world, and it breaks them down in terms of when you want to perform various cognitive operations involving numbers on paper. Like you want to compare which of two numbers is bigger, you want to multiply two numbers, these kinds of things. Then what is actually going on? What is happening in your brain in order to perform those operations, and how is that facilitated or not by the design of the number system and the particular notation that's reflected on paper? It's a really cool idea because to me this was almost like the kernel of the kind of work I hope to extend from something very basic like numbers to something more general like all of programming. But this is, I think, a better articulation of the style of like systematic cognitivist work that I hope to do than almost any other paper that I've seen. And it's also just fun. If you like number notations, there's a lot of good stuff in there. And the final paper I'll recommend is there's a great paper by Amy Coe. It's fairly famous in HCI called Y Line. There's several, but I think the original one is pretty good. Does a debugging interface for asking questions about human behavior. So I think this is just a really good instance of what human-centered programming design looks like in practice and how to make a really effective tool for helping people do something like debug programs in either a simplified setting, like this paper was about the Alice game engine, I think. Oh, and then they also translated it into Java. But also, to my point about user studies that don't show anything, I think Amy did a really remarkable job in this paper because their tool made people like 8 times faster at the various tasks that they were doing. It was just because I think that's the thing. When you do your job well, I think there are huge gains on the like being left on the table that people who are good at this can build the right tools and make people significantly more productive. At the individual tasks of programming, but it just requires a very deep understanding of why people struggle and what kind of support that they need. And I think this is just a very cool paper that neatly encapsulates a lot of ideas about not just understanding the world, but how to build a better one, which is something I hope to do too.
Wonderful. And
Oh, and then,
finally, reminding, yeah.
no, sorry, what was the last question?
Oh, no, no. This was just like about your lab and yourself and PhD students who might be interested.
Oh, yeah, that's right. So, the Cognitive Engineering Lab, which is the new lab that I'm making at Brown, cel.cs.brown.edu, we are recruiting graduate students, our first batch. So, feel free to apply, or email me if you want to talk about the lab. You can. My email's on my webpage at willcrichton.net, and I would love to chat with anyone who's interested in any kind of education, human factors stuff for PL, or even just technical things around like how do you make a more interesting version of Rust? How do you design a programming language to solve the world's problems? All of these things are interesting to me. Oh, one thing I didn't talk about this entire time, but I have to throw in at the end is if you don't like LaTeX and you're like, man, we really should have better tools for writing documents. Uh, do I have a 3-hour conversation for you? But I'll save that for another time.
It's amazing. And I'll add an additional shout out just for Will's webpage, which is a work of art. I really, really enjoy going to Will's webpage just to see what good design and good web pages should look like.
Oh,
I think
thanks.
one of the really nice things is if you're interested in this kind of work, there's actually a lot of details already on the webpage that you can read about his work and the ideas that inspire him and he thinks about. So highly encourage people to think about applying to Brown. It's a wonderful place. Providence is lovely, and as you all can surely tell, Will would be an awesome PhD advisor. Thank
Thank
you
you.
for coming on the show, Will. It was great.
Yeah, thank you both for having me. This is fun.
Thanks, Will.
Yeah,
Okay.
we'll
And that was the stream. I'll keep an eye on chat for like 5 minutes after for last questions that we can put in like the YouTube or in an email to Will. But other than that, thanks for coming. Super excited that season 2 is kicked off with such a great episode.
Yeah, this is great. I'm glad I could set up the stage for May. So you'd be like, I wonder what tools could help improve over the state of ownership type systems.